Welcome to iLecture Online, and here's some more physics for you. Today we're going to talk about capacitance and capacitors. And just to remind you what those things are, a capacitor is a device, an electrical device that's able to hold charge. So you can push charge on it, you can hold it. It's like a suitcase that you can put charge into. And capacitance is the ability of an object to hold charge, how much charge it can hold. What is the capacity for the capacitor to be able to hold charge? How much can it hold? All right. So here we have an example. It says a capacitor has a capacitance of 2.5 microfarads. How much charge can be placed on the capacitor with a 50-volt power supply? So it's always a good idea to draw a picture of that. So here's a picture of a capacitor, and usually a capacitor is depicted as two metal plates opposite one another, parallel to each other, a small distance apart from each other, and that's then connected to a power supply. So let's use a battery symbol to denote the power supply. So the power supply has a voltage of 50 volts, and the capacitor has capacitance of 2.5 microfarads. And so then this is the positive side of the battery, the negative side of the battery. So the battery will be pushing charge onto the capacitor, and the capacitor will fill up with charge. That will push the positive charges away from the other side, and so the capacitor will now be charged. And in order to find the charge, how much charge can be placed, that's what we're looking for. How much charge can we place onto this capacitor? Then we can find that in two ways. We can find it by using the equation. Actually, there's only one equation that will help us find this one. So let's try this one. The definition of capacitance C is equal to the ratio of how much charge can be placed on the capacitor divided by the voltage that pushes charge onto that capacitor. So that's by definition the capacitance of a capacitor. So think of a battery or a power supply as the object that pushes charge onto something, or that pushes charge through a circuit. And so the bigger the voltage, the bigger the power supply, the more charge you can put on the capacitor. And the capacitance is simply the ratio of how much charge you can put on there divided by the voltage that puts it on there. So plugging, well, actually what we need to do with this equation is solve for the charge. So Q is equal to C times V, and Q is equal to the capacitance, which is 2.5 times 10 to the minus 6 farads, because the microfarad is 10 to the minus 6 farads. And we multiply that times the voltage, and in this case the power supply is 50 volts. And let's see here, the charge then would be equal to 50 times 2.5. That's 125 times 10 to the minus 6 coulombs. And that's how much charge we can place on that capacitor. So with a 50-volt power supply, you can push 125 times 10 to the minus 6 coulombs on a capacitor with a capacitance of 2.5 microfarads. And that's a good example of how to use the definition of capacitance to work something out like that. All right, let's do another example.